Hello. So Dieter, you have been working as an engineer in several architectural and engineering offices and have quite a long experience in renewable energy sector and the latest years, especially within building integrated solar modules.
So the first question maybe for you, why is a small solar company like Ertex Solar from Austria is attending such a big MODER project, EU-funded project? We are really the smallest partner, let's say with the smallest budget. I'm not the smallest one. But we find it very interesting because there are some ongoing things like this, maybe you know the EU directive about near zero energy buildings, and I always ask how should it happen. So you need some resources on the building or close to the building, which makes your building near zero energy or maybe plus energy. So this is very interesting for us. And yes, and when you see on the photovoltaic market, you see always panels on the roof or somewhere in the green field, and we think that we need a broader perspective about how to integrate solar panels. So this was also one of the reasons to attend to this building, and it's a very important issue to influence also the design process, the planning process, if you are interested to integrate solar into your building. And I will show you afterwards some pictures about the long-term perspective when you integrate solar. Yes, and it's also a question about the software solutions up front before you go to integrate it. Yes, and we realized about 1,500 projects the last 10 years, and so it was my aim to integrate my know-how also into this project. One slide, who we are. So you can see here we started the very early design process, speak with architects, facade companies and so on, owners also. And when it comes to supply, we are the specialist in doing special solar panels. So we don't have the whole system, we don't build buildings, but from my perspective is a very important issue, how to integrate the panels. One of my work package in this MODER project was 2.2, my deliverable. It was about availability and suitability of renewable energy in buildings or in districts. And we made a big survey, so a lot of different technologies, heat technologies, electricity generation, cooling technologies, and then the storage also, combined systems, and also net metering. So it was really a big work package, and if I say availability and suitability, these are total different measurements, because available, a lot of things, for example, think about hydropower, but I don't know if there is any new resource or free resource in Helsinki about hydropower, but maybe in other districts or cities it's available. And we found a lot of different slides and pictures during our research, and this is one what I really like. This is a city of Graz, and you see these are the areas. If you try to cover the whole heat demand for city of Graz only with biomass, and interesting is if you make it with solar thermal. So you see there is maybe a kind of competition between different technologies, but this slide for me shows very well that there is maybe a big future also for solar. But what you have to consider, you can store biomass very long, and you can't store solar thermal energy maybe for one season, but not longer. But there are some initiatives going on to build also big storage for solar thermal installations. So this is one of my, let's say, conclusion out of this research, is that this is the kind of pyramid like Maslow, you know, on the peak there is self-fulfillment or something like that. And so there are some technologies, and BIPV, we call it BIPV for Building Integrated Photovoltaic, is on top of this pyramid, because, you know, hydropower it's a kind of workaholic, and it's a very low cost energy source. Biomass, there are some benefits, you can store it, but yes, on the other hand, when you burn it, you have pollution and so on. And PV, I don't know if you have seen installations in Germany, so they're mainly on greenfield, and so they're wasting, let's say, also the landscape. So from my perspective, the only thing where photovoltaic can survive is to integrate it into the building. And if you don't do it, and this is a collection of slides which I've collected over the last 10, 15 years. If you don't do it, then you will have projects like this. So this is, it's a kind of add-on, so it's not integrated. And this is really driven by subsidies, by feed-in tariffs. You see, the guy made no consideration about if is it portrait or landscape orientated. And there is a combination also with solar thermal sometimes. And the guy cutted some trees here only to bring some panels into position. And this is one of my favorite, and I think this is the reason why I'm also attending to this project, because we speak about cities, and it's not only energy consumption, energy production. We have to integrate it really into our landscape. This is, for example, from a German municipality. It's a negative example. They say it's not allowed to do things like this. Yes, and here also. And by the way, it's also not allowed from the technical perspective, because it's not a building product. It's an electrical product which produces energy, but you can't use it as a building product. There's another one in Switzerland. But go on the nicer solutions. What we always say is we need some kind of multifunctionality. So it's on one hand weather protection, so we can use it as a facade system. You integrate the solar cells into the insulated glass, also for conservatories and so on. Sometimes it's only aesthetical integration. When you speak with architects, they like to. It doesn't matter how much energy will come out. But this is, for example, a noise protection wall in Vienna. Also another one in Germany. Yeah, so there are a lot of different possibilities how to install. Only small slides. I will show you afterwards some bigger ones. And this is always what you have to have in mind when you go to building. It's always a question about multifunctionality. If you need only energy supply, then put it somewhere on the roof, maybe in a nice way. But in this case, it's always an additional function. Okay, and why I'm speaking about shading, the best orientation in buildings is maybe here in Finland, it's not 30 degrees to south, it's maybe a little bit, 40, 50 degrees, something like that, because you have a lower angle of the sun. And you have always to consider if there are some buildings in the environment. I like to show it with this example. It's a ski. It's a lift for in a ski area, and so they try to also to make it a little bit greener. But what you can see here, there is a trash bin, and for a PV installation, it's not really good if you have shadow here. They can move it a little bit away, half a meter, and everything is fine. This is a very small example about misplanning, let's say. But why I'm telling you about this is because in this project, this is a very popular project in Vienna. It's called Energy Base. This project you see here is a normal insulated glass facade, and on every line here is a solar array, and on top also another one. And they built a new building just in front of this building, and so that means the whole design of the building, it's gone. So the energy production, you see it also from the other perspective. So this is an existing building, and here is the new building, and so it's really in front of this solar facade. And when you see it in a sketch, in summer it's maybe no problem. So because the angle of the sun is very very high, but in winter, especially the arrays on the bottom will be shaded. So it's not only shading of the solar panel, it's also, let's say, the passive energy consumption for the building itself. And so I think this is very important when you go on a district level refurbishment and also new build like here, to consider these issues. I will speak about two key stakeholders in the project. One is the architect, and this is a big trend at the moment. that they don't like the normal design of a solar panel. So, question to the auditorium: do you think this is a nice installation of a PV facade? No, yeah, but the guy who made it is this CEO of the Swiss Solar Foundation, and this building looked like this before. Yes, so it's a kind of Jugendstil in German. I don't know, Art Deco. I don't know. And he made this renovation, like this. And his perspective was only to say, okay, I can make a plus energy house out of my old building. And in Switzerland, to be honest, the architectural community said, we don't want to see this because it's it's not the right way to do it. But on the other hand, the owner of the building said, I want to show it that it's possible. And I think we should find a way in between. And that, let's say, from the historical point of view, a solar panel usually looks like this. You see this metallic wire. Some of the architects say, we like to see it because we want to see that our building produces energy. On the other hand, some of the architects say, we like to have this more or less homogeneous design, so it's very easy to do. You only have to cover the tapes, then it's homogeneous. And the next step at the moment is, you see here is a wooden facade, and we printed some color on the panel to have a similar design like this wooden area, and you lose around 10-12% of efficiency of the panel. So this is at the moment a big trend, especially from Switzerland. This is also possibility how to do it with green solar cells. And this is a project also from Switzerland. It's an apartment building, and you see there's a very structured glass, and it looks more or less red because there's also a print on the inside on the glass, because the architect also said, I don't want to see it from the first perspective that it's a PV installation. And he made also the north facade, the roof, all facades covered with PV. So these are the trends which are ongoing and new possibilities. Are there some architects here in the auditorium? Okay, a few, perfect. Yeah, good. And the other one, which I like to speak in the last 3 minutes, is the more or less engineering approach. Because usually when you consider to integrate solar panels, it's only energy production, but you can reduce also your energy load when you integrate solar panels. And you can see it here in this installation. This is a facade. It's a kind of semi-transparent solution. You see the trees outside. And this is an energy center for energy supplier, German energy supplier, and it was a kind of showcase how to integrate solar panels in this cube. They try to build a globe because it's the best ratio between volume and surface, but it was hard to build, so they decided to make a cube with 15 to 15 meter and integrated some solar panels. And there are two effects. One is the energy production. The other one is the reduction of the cooling loads. And this is what I like to show in the following slides. So here's another example. And yeah, so this is, you see the cells are perforated, so there are small holes inside. From the energy perspective, it doesn't make sense to drill holes in a solar cell because you reduce the power. But from this kind of shading device, shading element, it makes sense. Yes, and the reason, or let's say the physical parameters behind this, if you have a solar radiation, you have a kind of transmission, so it's the first value, then you have a reflection and absorption, and one part goes outside, one goes inside, and this is the so-called G value, and the G value is important about the question how much energy you need to cool down the building. And we made some research also related to the MODER project. So a student is doing some research on different buildings, also kind of refurbishment, because this is a university in Vienna, and you see this. There is a big glass facade and also a big glass roof, and inside this building you can measure about 30 degrees during the summer because of this solar impact. And we said, okay, what could we do with this glass roof here? It's a quite big area from Google perspective. This is, by the way, a cadastral map in Vienna. You can click on every building in Vienna, so they surveyed it, and then you can see the energy possible energy which you can provide from solar thermal or photovoltaics. So it's quite interesting. And in this case, we said, okay, we can install around 55 kilowatt peak on this glass surface. And the interesting number for this installation would be, on one hand, you can produce about 50,000 kilowatt hours renewable energy per year. And what is more interesting from my perspective, you can save around 60,000 kilowatt hours on your electricity bill, because you reduce your cooling loads because of the solar cells which are integrated. So I have only 19 seconds. Okay, so I'm still finished. Yes, if you have any questions, I'm available. Yes, also in the coffee break. Thank you.
Thank you so much, Dieter, and thank you also sharing these planning failures in a very concrete way. Questions, comments for Dieter?
Okay, maybe not in the say of the architecture part, but more in the engineering part, and it's like about the efficiency and the production of energy of the panels that you manipulate. You say that you were painting the surface and generating some different like textures.
Mm-hmm.
It's like printed over the glass part.
Mm-hmm. Yeah.
And then if you say that reduce 12%, already is proof that actually the performance of the panels will reduce by considerable over the years. Then how is the impact of those reductions and also the manipulation of the panels in the future of the building? Like,
yeah, there are some, let's say, some issues about degradation. We call it degradation. So there is basically a minor degradation of the solar cell. The only thing what could be that the glass will be scratched more or less, and then you have less energy which goes on the cell. So what I know, it's about 0.3% per year, approximately, the degradation. Yes, and so to be honest, if you put a PV panel in a facade system, you have, compared to an inclined system, approximately 20 to 30% less energy output. You know, so this is very interesting for me that a lot of people are going into facade systems, but the energy output is quite low. So there are other perspectives or other interests in doing things like this.
do you have some kind of tool for like
Calculation? Yes, there are some tools available. On one hand, there is a European website, so it's a very, I can give you the address in the break, a very rough tool where you say the surface or installed power, is it facade, is it inclined, the location is very important because of the weather data. So it's a very rough calculation, but you can go also on very precise detailed softwares, for example, Revit from AutoCAD, or also the inverter producers. You know, you need inverter to transform the direct current into alternating current, and also this inverter producers provide also software to calculate the power output. Mm-hmm.
Any other questions, comments? I have one. In Finland, the solar energy, being it then integrated or not, is coming somehow desperately slow. So how to make it trending also in Finland? What would be your advice?
You know, from my perspective, there was a big growing rate in all over Europe, and it was driven by standard module production and brooded on greenfields and roofs and so on. But this is not trendy anymore, so it's only really on very low cost energy production. sometimes you can compete in different countries. For example, I've heard today in the morning that the energy price for an end consumer here in Finland is around 10 cents per kilowatt hours. In Germany, it's 30 cents. So they are investing also in batteries to, let's say, to reduce their own energy bill. I don't know if they ever calculated how much the battery will cost, but what we found out in the last years is if we work together with architects and try to bring really nice panels into the building, in the facade, in the roof, then it will grow automatically. And to be honest, in Finland you have maybe less solar radiation like in other cities or other countries in Europe, but the temperatures are also lower, and that means the efficiency is better than in, let's say, Saudi Arabia or something like that.
Exactly. Thank you so much, Dieter, once more.
Okay.